Hello everyone, I am Chirag Gulati and this is my submission for the Altair Data Science contest being held in BITS Pilani, Hyderabad campus. So today, let's see how we can solve a data science problem using RapidMiner. First, let's start by understanding what is RapidMiner. So, RapidMiner is a data science platform by Altair that can be used for data preparation, text mining, predictive analytics, and machine learning. It can be very useful for professionals who want to analyze data but don't have a lot of coding experience, as it is very easy to use with its easy to understand graphic user interface and the operator blocks. Let's now check out the data science problem that we will solve with RapidMiner today. We are going to try to solve the Spaceship Titanic competition from Kaggle, which is an online community and platform for data science competitions. So, in this competition, our task is to predict whether a passenger was transported to an alternate dimension or not. So, basically, it's a classification task. To help us make the predictions, we have been given a set of personal records recovered from the ship's computer system. I'm sharing the Kaggle link with you in the PPT right now for the competition dataset. So, now let's start by importing the dataset into RapidMiner and having a look at it. So we import the dataset into RapidMiner using the retrieve operator. So after running this, this is the dataset. These are the columns of the dataset, the first one being passenger ID, which comprises of four numbers, then an underscore, then two numbers. The first four numbers represent the group that the passenger is traveling with, and the last two is the number of the passenger within the group. So from this we understand that the last two numbers can be used to find out how many people are traveling together, which can be an important factor in predicting if they were transported successfully or not. The second one is the home planet. This is the planet that the passenger departed from. Typically, the planet of permanent residence. The third column is cryosleep. Now, this indicates whether the passenger was put into a sleep state for the duration of the voyage or not. Passengers in cryosleep are confined to their cabins. The next one is cabin. So this is the cabin number where the passenger is staying. It takes the form of deck slash number slash side, where side can be either P for port or S for starboard. The next one is the destination. Now this is the planet that the passenger is going to. The next is age, which is pretty self-explanatory. Next is VIP, which tells us whether the passenger has paid for special VIP services or not. Then the next five, which is room service, food court, shopping mall, spa, and VR deck, these are the billings that the passenger has done in the ship's amenities. Then the second last one is the name, which is the first and last name of the passenger. And the last one is the final one, which is the label that tells us whether the person was transported successfully to the destination or not. So, over here in the stats, we can see that a lot of values are missing for cryosleep, for all the billings, home planet. So now we're going to start filling in these missing values in the data pre-processing part. So let's move on. So see, a machine learning model cannot very easily make sense of data that's in any other form than numerical. So trying to convert all the data into numbers and dealing with all the missing data is a big part of data pre-processing. Now it's all done under this sub process so as to make it seem as tidy as possible. Now under this sub process, these are the tasks that I've done. First, I've generated a deck and a side column using the cabin column that we were given. For this, I use the function description in the generate attributes operator. Next, I removed the name and the cabin columns as they weren't very important for building the model. Then using the passenger ID column and an execute Python block, I generated a group size column which tells us the number of people that each of the passengers is traveling with. The execute Python block is one of my favorite parts about using RapidMiner. Then next, I filled in the missing age values with the method of mean imputation and then I replaced all missing values of billings to 0. Then in six different sub-processes, I filled in the missing values of cryosleep, home planet, destination, VIP, deck, and side values. These were all done by the uh, mode imputation. Then I converted the cryosleep and the VIP from text-based columns with true and false values to ones and zeros. After that, I finally converted the target attribute to a label and then applied one hot encoding on the deck, destination, home planet, and the side column. So after running this, yes, so this is now our final data set with zero missing values and with all of the values now being either real or integer type. So, which is very easy for the model to understand. With this, our data pre-processing is over and we move on onto our next step, which is splitting our data into training and testing sets to test out our model on unseen data in the end. We now use the split data operator for this and divide our data into two parts. The testing set that comprises of 80% of our data and the test set with the remaining 20%. Our next step is now going to be feature scaling of the data. So let's run the train test split first. Now we have the test set, the train set and the test set. So now, before applying feature scaling, let's first understand why we need feature scaling in the first place. So, real world datasets often contain features that are varying in degrees of magnitude, range, and units. Therefore, in order for machine learning models to interpret these features on the same scale, we need to perform feature scaling. For our purposes, I have used the min-max scaling, which uses the range transformation to transform the data between 1 and 0. So I transform my training set and then I apply the same transformation to the test set as well using the apply model block. This is done because I want my test set to be completely new for my model. Now after running this is our training set where we have all of the values between minimum of 0 and maximum of 1. So now we've feature scaled all of our columns. Now our data is prepared to be fed to a model so that it can train on it. And then later we can test it to see how it performs on the unseen data. We will here hyperparameter tune and then compare 5 different models and choose the one that performs the best with our dataset. For this, we will use a few operators. First, we have an optimize parameters grid operator which will return us the model that gives the best cross-validation score in the select subprocess operator, where we have 5 different optimize parameter grid operators, one for the generalized linear model, one for the deep learning operator, one for logistic regression, one for gradient boosted trees, and one for random forests. In these hyperparameter grid operators, we are cross-validating our models with 10 number of folds, as we can see over here. Then the best model comes out of this main optimize parameters block and goes to the apply model where we also get our test set. So over here, we are applying the best performing model on our test set and then calculating the performance on the unseen data using this performance operator. Now let's run the models and see the results. So this processing is now going to take a very long time. So with the help of a little video editing magic, let's meet at the end of our processing. So now these are the final results that we get after the processing has been completed. Over here we got a cross validation accuracy of 79.68% from our second subprocess. Let's now check out which one was our second subprocess. So over here we can see that the second subprocess was the deep learning model. Also, as we can see in these results, on the unseen data, this model gave us an accuracy of 79.47%, which is pretty good. Now, this is already a pretty good model, and this will help us with the selection of passengers when sending them in space. But still, there lies a big scope of improvement in our model, which can be done with more data. As the more data that we train our model on, the better it becomes. And when given more time and a stronger machine to work with, we can try to optimize the models even more by more hyperparameter tuning. Thank you so much for watching this video. Have a nice day.